Dear friends, in this video we are going to discuss about the computational complexity while finding discrete Fourier transform using the methods direct method, that is a formula method, versus FFT. You have two FFT, one is DIT method, decimation in time, decimation in frequency. Now we are discussing about two operations. One is complex additions and another one is complex multiplications. First we will discuss about direct method. In both the methods, to find the computational complexity you should know the formula. For direct method, number of complex multiplications formula will be n square. Now we can consider n is equal to 28. In the examination you may have n is equal to 64, 128, 256, 512, 32, 8, 16, etc. Everything will be in the power of 2 power n. Okay. Now we are considering n is equal to 128. So 128 square, which is equal to, if you use calculator, 128 square will be 16,384. This is number of complex multiplications using direct method. Now we can find number of additions. Number of complex additions. The formula will be n square minus n. If you substitute n is equal to 128, you will get 128 square minus 128. If you use calculator, you will get 16,256. Next, we will discuss about FFT. Fast Fourier transform, as the name indicates, it has very less number of computations to find discrete Fourier transform. First we will discuss about number of complex multiplications. The formula will be n by 2 log n to the base 2. We have considered n is equal to 128. If you substitute 128 by 2 log 2 128. Now this 128 can be written as some integer power of 2. If you use 2, you will get 64. If you use 2, you will get 32. If you use 2, you will get 16, 2, 8, 2, 4, 2, 2, 1, 2, 3, 4, 5, 6, 7. So this 128 can be written as 2 power 7. 1 2s are 2, 6 2s are 12, 4 2s are 8. 64 into this power 7 comes as multiplication. So 64 into 7 into log 2 2. Now 64 into 7 into log 2 2 value is 1. We have a basic formula, log AA is equal to 1. So you will get 64 into 7, which is 448. This is for number of complex multiplication and it is for n is equal to 128. Now we can find complex additions. In the case of FFT, complex additions, the formula will be n log 2 n. Our case is n is equal to 128. So 128 log 2 128 log 2, as we know 128 can be written as 2 power 7. This power 7 will be comes as multiplication. 128 into 7 log 2 to value is 1. If you use calculator 128 into 7, you will get 896. So we have found for DFT, to find DFT, we have checked for both direct method and FFT method. In the case of direct method, the values are huge. But in the case of FFT, fast Fourier transform, the values are very, very less. For n is equal to 128, direct method needs 16,384, 16,256 complex additions. But in the case of FFT, the values are simply 448 and 896. The values are very less in the case of fast Fourier transform. That's why this method is called as fast Fourier transform. Thank you.